The bones in the net. For decades, fishermen working the North Sea have been pulling up things that should not be there. Mammoth teeth, woolly rhinoceros bones, antlers carved with geometric patterns, stone tools, and occasionally, human remains. Not from shipwrecks, not dumped overboard, dredged from the seabed itself, from depths of 30 to 50 meters, tangled in nets meant for sole and cod. The fishermen call them lucky catches. To scientists, they are something else entirely. Evidence. Evidence that the sea floor they are trawling was once dry land. Evidence that people lived there. Not thousands, but tens of thousands of years ago. Evidence of a world that no longer exists. There's a name for this drowned country. Archaeologists call it Doggerland, named after Dogger Bank, the shallow fishing ground where the finds are most common. And over the past 2 decades, technology has allowed us to do something that would have seemed impossible a generation ago. We have begun to map it. What we have found is not a few scattered islands or a narrow land bridge. Doggerland was a country, a landscape larger than the Netherlands, connecting Britain to mainland Europe. It had hills and valleys, rivers and lakes, forests and marshlands. It had coastlines, estuaries, and what may have been some of the richest hunting grounds in prehistoric Europe. And then it vanished. Not slowly, not gradually, but in stages, and perhaps, at the end, catastrophically. The people who lived there did not see it coming. They could not. The forces that drowned their world operated on timescales they could not perceive and with a speed they could not escape. This is the story of Doggerland, a world beneath the waves. Let us go under. The North Sea is not a good place to do archaeology. Visibility underwater is measured in centimeters, not meters. Currents are strong, weather is unpredictable, and the seabed is constantly shifting. For most of the 20th century, everything we knew about Doggerland came from accidental finds, bones and tools pulled up in fishing nets, or occasionally by dredging operations. Then came seismic surveying. Oil and gas companies have been shooting sound waves into the North Sea floor since the 1970s, mapping the geological structures below to find hydrocarbon deposits. And in doing so, they inadvertently created something else, the most detailed maps of the ancient landscape that anyone had ever seen. The key is understanding how seismic reflection works. You send a pulse of sound into the ground. It bounces off different layers: sediment, clay, sand, bedrock, and returns to your receivers. The pattern of reflections tells you what is down there, and crucially, what shape it is. In the early 2000s, a team led by Professor Vince Gaffney at the University of Birmingham began systematically analyzing oil company seismic data covering thousands of square kilometers of the North Sea floor. What they found was astonishing. Buried beneath meters of marine sediment, they could trace ancient river channels, not small streams, but major waterways, some as large as the modern Rhine. They could see where rivers joined, where lakes formed, where coastlines had once been. They could identify hills and valleys, marshlands and estuaries. They were looking at a landscape, a complete, coherent landscape, frozen in time beneath the waves. And it was huge. At its maximum extent, during the coldest phase of the last ice age around 20,000 years ago, Doggerland connected Britain to Denmark, the Netherlands, Germany, and France. The English Channel did not exist. The North Sea was a vast plain, crossed by rivers that drained the melting ice sheets. Even 10,000 years ago, when the ice had largely retreated, Doggerland remained, smaller but still substantial. An area perhaps the size of the Netherlands stretched between what is now eastern England and the European mainland. The seismic mapping allowed researchers to do something remarkable: reconstruct the human geography of a world that has been underwater for 8,000 years. They identified areas that would have been prime locations for settlement: river confluences, sheltered estuaries, lake margins. They traced what may have been migration routes, connecting the highlands of what is now Britain to the European mainland. They even found what appears to be a massive salt marsh complex, exactly the kind of environment that supports abundant bird life, fish populations, and the humans who hunt them. Doggerland was not marginal territory. It was not a wasteland that people crossed to get somewhere else. The data suggests it may have been the best land in Northwest Europe. To understand why Doggerland mattered, you have to understand the Ice Age. For the people living in Northwest Europe 12,000 years ago, the world was just emerging from a deep freeze. Ice sheets that had covered Scandinavia and much of Britain were retreating. The climate was warming, but slowly and unevenly. And crucially, sea levels were much lower. So much water was locked up in continental ice sheets that global sea levels were about 60 to 120 meters lower than today. That is not a small difference. That is the difference between a North Sea and no North Sea. The land that emerged was not Arctic tundra. By 10,000 BCE, Doggerland was temperate, even lush. Pollen samples from sediment cores show forests of birch, pine, hazel, and oak. The animal bones pulled up by fishermen tell us what lived there: red deer, roe deer, wild boar, aurochs, the massive wild cattle of prehistoric Europe, and occasionally predators like wolves and lynx. The people who lived there were Mesolithic, Middle Stone Age, hunter-gatherers who followed the game, fished the rivers, and gathered plants from the forests and wetlands. We know they were there because they left things behind. The most famous single artifact is probably the Kalinda Point, an elaborately barbed antler point, likely used for hunting or fishing, dredged up near the Lehman and Ower banks in 1931. It was clearly worked, clearly human-made, and clearly came from the sea floor. But it is not unique. Hundreds of stone tools have been recovered from the North Sea over the decades. Flint blades, scrapers, cores, antler hammers used to shape stone, the toolkit of people making a living from this landscape. And then there are the human remains themselves. In 1985, a trawler fishing near Brown Bank pulled up a fragment of human skull. Radiocarbon dating placed it at approximately 13,000 years old. A person who lived and died on Doggerland, millennia before the pyramids, before Göbekli Tepe, before the first farmers. Their bones had rested on what was then dry land. The sea came later. Recent archaeological analysis suggests these were not marginal people eking out survival at the edge of habitable territory. Doggerland may have been optimal territory. The combination of marine, freshwater, and terrestrial resources in close proximity would have made it extraordinarily productive. Coastal wetlands support enormous biomass: shellfish, fish, waterfowl, seals. River valleys provide fresh water, timber, and access routes inland. Forests offer game and plant foods. The people of Doggerland may have had it better than their contemporaries on the highlands of Britain or the plains of northern Germany, which makes what happened next a particular tragedy. They did not leave because life was hard. They left, those who could, because the water rose. The drowning of Doggerland was not a single event. It was a process that accelerated. At the end of the last ice age, around 20,000 years ago, sea levels began to rise as the continental ice sheets melted. But the rise was not linear. It came in pulses. For thousands of years, the rise was slow enough that coastlines moved gradually, a few meters per century. People living on Doggerland would have noticed the shorelines shifting over a lifetime, but it would not have felt catastrophic. The land was shrinking, but slowly. Then came meltwater pulses. When ice sheets collapse, not melt but structurally fail, they can release enormous volumes of water in geologically brief periods. There is evidence for at least 3 major meltwater pulses between 14,000 and 8,000 years ago, each potentially raising sea levels by meters within centuries. For the inhabitants of a low-lying coastal plain, this would have been devastating. By around 8,000 BCE, what had once been a vast plain was reduced to an island, sometimes called Dogger Island, roughly where the Dogger Bank Shoal is today. Sea levels had risen perhaps 40 to 60 meters from their Ice Age low. The remaining island was still inhabited. Stone tools from this period have been found in the area. People were still there, adapting to an ever-shrinking homeland. And then something happened that may have delivered the final blow. Storegga. Around 6,200 BCE, give or take a century, a massive undersea landslide occurred off the coast of Norway. An area of seabed roughly the size of Scotland suddenly collapsed, sliding down the continental slope into the deep Atlantic. The displacement of water was catastrophic. The resulting tsunami sent waves across the North Sea that may have reached 10 to 20 meters high at certain coastlines. The eastern coast of Scotland preserves tsunami deposits, layers of marine sand carried far inland by the wave. Similar deposits have been found in Norway, Denmark, and the Shetland Islands. For a low-lying island already reduced to a fraction of its former size, already stressed by rising seas, Storegga may have been the end. The timeline matches. After approximately 6,200 BCE, there is no clear evidence of human presence on what remained of Doggerland. Whether everyone died in the tsunami, or whether survivors fled to higher ground in Britain or mainland Europe, we do not know. But within a few centuries of Storegga, the North Sea had claimed the last of it. The Dogger Bank became a submerged shoal, 15 to 35 meters below the waves. A country had vanished. The people who had lived there, who had hunted its forests and fished its rivers, who had known its landscape as home, they were gone. Some of their bones remain on the seabed. Some of their tools wash up in fishing nets. Everything else is beneath the waves. What Doggerland tells us. 2300 to 2800. Doggerland is not just a curiosity, it is a warning. The people who lived there did not cause the flooding. They could not have prevented it. They were bystanders to planetary forces operating on scales beyond their control or even their perception. Sea level rise at the end of the Ice Age was natural, driven by orbital variations, ice sheet dynamics, and feedback loops in the climate system. No one was burning fossil fuels. No one was releasing gigatons of carbon dioxide. And yet, the rate of sea level rise we are currently experiencing, about 3 to 4 millimeters per year and accelerating, is comparable to the faster phases of post-glacial rise. Some projections suggest we could see 1 to 2 meters of rise by 2100. That does not sound like much until you realize what it means for low-lying coastal areas. The Netherlands, Bangladesh, Miami, Shanghai. We are not facing the exact same process, but we are facing the same physics. The science of Doggerland is far from complete. In the past decade, researchers have begun using new techniques, ancient DNA from sediment cores, high-resolution sonar mapping, even dives to specific target locations identified by seismic data. We are finding more. In 2019, archaeologists announced the discovery of what may be a Mesolithic forest preserved beneath the sediment off the Norfolk coast, tree stumps and fallen trunks from the forest that once covered Doggerland. In 2020, A study of Doggerbank sediments revealed peat layers containing pollen, insects, and plant material that allowed reconstruction of the environment in unprecedented detail. We are getting better at reading the drowned landscape. Every year, the picture becomes clearer, but the core story does not change. A world existed, people lived there, and then the waters rose. I think about this from Istanbul, a city built on a peninsula, surrounded by water on three sides. The Bosphorus that I look out at every day was once a river valley. The sea came here too. The fishermen of the North Sea still pull up bones. Every year, trawlers working the Doggerbank recover artifacts from a world their distant ancestors might have known. Most are deposited in museums. Some are kept as curiosities. All are evidence of something we find difficult to fully absorb. Coastlines are not permanent. The familiar geography we see on maps, the shapes of countries, the boundaries of seas, is a snapshot, a still frame from a movie that has been running for millions of years and will continue long after we are gone. Doggerland reminds us that the land we stand on is borrowed. The sea has come before. The sea will come again. The only questions are when and how fast, and whether we will see it coming. The people of Doggerland did not. They left their bones on the seabed, and we pull them up in fishing nets, and we try to understand what their world was like. We try to understand what we might lose. The investigation continues. If you want to know what the evidence shows next, and where it ends, join the excavation. Tell me in the comments, which collapsed civilization should we examine next?